In this video, I'm going to be walking you through an implementation of a singly linked list and talking briefly about a doubly linked list and what that would look like. So a singly linked list is a linear data structure, and it's basically a bunch of nodes that are connected to one another in a chain sort of like fashion, and you can traverse this chain by using those connections. So instead of just jumping into any index in the chain, you have to start at the beginning and traverse one by one, going pointer through pointer, all the way to the value that you want to look at. So this is very useful space-wise, and it's also a very helpful way to think about when you want to implement stacks or queues or other types of more abstract data types. So how you implement a linked list, a singly linked list, is you should have a node class. The node class will have each two different instance variables. It'll have an info, which will have the data that you're storing in your data structure, and it will have a next pointer, which will point to the next node in the list. So in this list node class, we also have a constructor that passes in an object and a next node, and also a default constructor that sets everything to null. So these list nodes are going to be used in your data structure to form the structure. So if we go to the beginning of my class, I have a singularly linked list. It has a head and it has a size. So the head is basically your starting node. It has no data, and the head is going to be where you start for all your functions, and it's going to point to the first data node in your list. So you have your head, you have a size to keep track of how big it is, and that's it. So in your constructor, you initialize these with a null node and size 0 for an empty list. A size function returns the size. A front function, so the front function will basically peek at the first index of the list and return the data stored in that front index. So to do that, we look, since the head doesn't have the data, it's going to point, we're going to take the pointer of the head that points to the next node, and then we're going to look at that next node and check out the data stored there. So basically, in code, that would look like the head dot the next, because we implemented the list node class in this class as a private class. It's just, you can access it using a dot. So head dot next, so you're going to look at the next pointer, and then the info dot info. So then we have an add function that takes in an object, and it returns nothing, and it will add this object to the beginning of the list. So we have a special case. If the list is empty, we are going to put the object right there in the beginning. So the head, the next one, will point to a new list node that we create and initialize using the object we passed in. It will increment the size and break out of the method. If it's not empty, we're going to create a new node called previous, which is going to be head.next, and we are going to set that node equal to the new list node. And then again, we're going to increment the size. So that's the add function, and then we have an isEmpty function that just returns true if it's empty. Then we have a remove function. This function will take in an object, remove the object, and return the value of the removed object. So basically the same thing you passed in. So first you create a list node I, which will first look at the first data, so the first element you have. This is what we're going to use to iterate. So we have a node, it's called I, and then we're going to make another node called previous, and that will point to head to begin with. So then we're going to iterate through the list. We're going to, as long as I is not null, so as long as we have something to look at the next one, we are going to check if the current element that we're looking at equals the object that we want to remove. If it does, we will remove the object and fix all our pointers, decrement the size, and return i.info. And then if this is not true, we will increment our previous node and our I node, and we will set them to the next node possible. After all of this is done, if we couldn't find this object in the list, that means there was nothing that could be removed, we just return null. So the contains method will return true if the object that's passed in appears in the list, and false if it's not. So again, we're going to do another iterating, so we create a list node I, which will equal the first element to start with, head.next. We're going to iterate through, so while I is not null, so while we have something to iterate over, we're going to check if the current one that we're looking at, I, is equal to the item, and if it is, return true. If not, we increment I to be the next one, we look at the next node, and keep going, and if at the very end we find that we haven't found the item yet, we simply return false. So the toString follows the basic Java sort of formatting for a string representation of a data structure. It will return them in square brackets. So basically, very similar to how we've done before, we check first if it's empty, because that's a special case and we have nothing in the list. We simply return square brackets with nothing in them. Otherwise, we create an iterable node. So I is going to be the node we're going to be iterating over, which will equal head.next, and then we're going to iterate through it, and each time we look at a new node, we will add that information to our S string, and then for formatting, we take everything minus the comma, because I included a comma, and then at the end return the string we have just made. So append adds a new item, the one that's passed in, to the end of the list, and makes it the last item in the collection. It needs only that object. So again, same as we did before, we're going to iterate through using a previous and an I node. We're going to iterate to the end of the list. So previous will always equal I, and I equals I.next until I is null. When it's null, that means we're at the end of the list, and we will make a new node using our constructor, and then we will place it into our line, our list, and then increment the size. So the function index of returns the position of the passed in object. It will return that index or -1 if it's not found. So as we do, create an I, which is going to look at the current one. We're going to iterate through the array. If the current one is equal to the object, we return a counter that we made. Otherwise, we increment the counter and check the next one. And then if we do all of that and nothing is found, we return -1. So value at returns the item that is the item at a specified position. So you pass in an integer and it will tell you the object at that index. This one is a little bit tricky because if you pass in something that is not valid, so if your list is too small, you pass in a number that's greater than the actual size, it shouldn't work, but we don't want it to throw an error. So first we're going to check for that. We're going to check if the position is greater than or equal to the size, we're going to return null because this doesn't work. Then we're going to again create an I to iterate. We're going to iterate through, and if the counter, which we're going to use to loop through and check, if the counter is equal to the position, we will return the information at that node. Increment if not, and increment the counter as well, and then return null if we couldn't find anything. So the pop function removes and returns the first item in the list, and it doesn't need anything, and it will return that item. So if it's an empty list, it's a special case, we return null. And if it's not empty, we simply create a temporary object, store the information from the first node, then we're going to create a temporary node and set that equal to the first node with data, and then rearrange some pointers around and to remove the first one, and also keep in mind data collection, so we want to remove all pointers pointing towards it, and we're going to remove all pointers that it has, and then we're going to decrement the size and then return our temporary data that we had in the beginning. So the next function is an insert function. This will add a new item that you pass in at the position that you pass in. So this is also very similar to the other ones we have done. It will first check validity of the position that you passed in, so it doesn't throw an error. And then it will check if the position equals the size. So if it's at the very end, we're simply gonna, because this is an easier case, we're simply gonna call append, which, if you remember, adds to the end of the list. We're gonna pass in the object and just simply break out of this. So if the two cases aren't true and it's somewhere in the middle that we wanna do, we wanna add that object into, we iterate through the list again, and if the counter that so we can keep track of the position, if it equals the one we want, then we add it into the position, and then increment all of our nodes. So indices of is very similar to index of, except this time we have an array list, an integer array list, that will keep track of all the indexes of that object that you've passed in, and then return that list. And again, similarly to remove, remove all will take the object and remove all occurrences of that item. It will again iterate through the array, iterate through the linked list, and then while the pointer that you're iterating with is not null, if the object equals the data at that point, you remove it, otherwise you increment it, and you keep going until the very end, and you've removed all of the occurrences of the item that you pass in from the list. So these are the basic functions of a singularly linked list in Java. Now, a doubly linked list is very similar, except instead of just having the data instance variable, the next pointer, you also have a previous pointer in the list node class. So it would look something like this: private list node prev. Now, if you notice, in a lot of our functions, what we did was we created a new list node prev, as you can see here, and we use that for our iterations. So having a doubly linked list makes this very easy because we have a previous pointer that is true for all of the nodes and is already created. Now, we are going to be covering a circularly linked list as well. I think that circular linked lists are, the definition of them is a lot easier to implement, a lot easier to think about than a doubly linked list, and is going to be the main focus of the next video. So yes, this is singly linked lists in Java.